Hey everyone, I'm glad you made it to continue progressing through this Java track. We're now on to the third video of the Java track. Progressed pretty decently throughout the course, but there's still a lot of information that needs to be covered. So without further ado, let's get right into the lesson. What I'm going to be going through today over the course of this lecture is going to serve as a foundation for which you're going to be able to build Java programs from here on out. What we're going to talk about today is very important on a day-to-day basis as a Java programmer. The concepts that you learn today, you're going to be using very frequently throughout your careers as Java developers. So it's very important that you understand this information at a very high level, but then you also understand some of the more intricate details of this as well. And if some things don't make sense to you, be sure to rewatch the video to help clarify some concepts. And what I've noticed is oftentimes pretty helpful for me is that even after rewatching videos, if things don't make sense, definitely scurry around the internet and find some answers to some of the questions that really pique your interest. And you can look at sites like Stack Overflow and a bunch of other forums for computer scientists so you can tap into the greater pool of computer science knowledge on a global scale. It makes it a lot easier for you to grasp concepts much quicker and with greater details as well. These are some of the technologies that we have available at our arsenal today that many people before our time didn't have access to. So it's important to go about and actually capitalize on these things so that we can continue to progress and develop our own computer science skills. So without further ado, let's get right into the introduction of the lecture. Sophisticated programs are oftentimes going to need to process different types of data, and this is going to serve a wide range. In order for a computer to really deal with this type of information, it needs to process this data. And it does so by A, allocating the space required to store some of the data that we're dealing with. And then B, you're also going to have to store the type of information that is being expected. The computer needs to know exactly what type of information is going to be stored in a specific block of memory. And this is very important because different types of data are oftentimes going to have different allocation requirements. So it's nice to know that up front so that the computer can go about actually manifesting this in the background so that you don't necessarily have to worry about it. And for those of you with backgrounds in other languages, you might recognize some of the types of data that we'll be going into depth on in this lecture. Some of these could be strings, integers, and even more data types. So stay tuned and hopefully you have some more data types that you haven't worked with in the past that we can touch upon today. Java has something that makes it very unique in the sense of data types. And it's this notion of primitive and non-primitive data. On the one hand, we'll have primitive data types, which are natively defined, and all this means is that these are the data types that come built in with Java. And this type of data merely specifies the allocation size of the information that's going to be stored, as well as the type of data that's going to be stored. So it still covers the two basic requirements that we talked about for processing data on the computer front, but it doesn't have the additional capabilities that we'll talk about with non-primitive data types, such as having associated methods. And all that really means is that you can't perform native operations without building your own functionality for some of these types of data. And we'll go into a little bit more depth on exactly what methods are a little bit later in the course, but for now, just know that that's one of the limitations of primitive data types. On the other hand, we have this notion of a non-primitive data type. And this is the type of data that the programmer must define themselves. When they write their own classes and create objects of those classes, this is exactly what we're referring to when we talk about that non-primitive data. And generally, because the programmer has to define this, we'll refer to this type as user defined. But there is one very special exception that we're going to go into depth on this course, and that's a string. I won't touch on it too much right now, but just know throughout this lecture we'll go into a bit more depth on it, and hopefully that clarifies some of what I'm referring to at this point. And the power of non-primitive data types is that you can have methods associated with that type that perform specific operations on the data that's stored in that sphere. Right, so you can perform a lot of additional functionality that helps you create very sophisticated programs with high level of flexibility and high level of capability. And this is exactly what we'll go into depth on when we talk more about object-oriented programming. But what we'll cover throughout the course of this lecture, at least, is the notion of strings and how we can use some of the built-in functions for strings that make it such a powerful data type for us to leverage in programs that we write. So now that we've talked about the concept of primitive versus non-primitive data types, let's go into some examples on what are some primitive data types. The first one I want to touch upon is a byte. And a byte can store whole numbers in the range of -128 up to 127. And if you wanted to store anything that's smaller than -128, a whole number that's smaller than -128, or a whole number that's larger than 127, you wouldn't be able to do so in a byte, and you'd have something called an overflow error. We're not going to talk about that too much right now. Maybe in an advanced version of this course, we can cover some concepts like that, but just know that the type byte is going to be incompatible for those types of situations. We'll also have a data type that is short, and this will be able to store whole numbers in the range of -32,768, and it goes all the way up to 32,767. Again, if you want to store numbers that fall outside of this range, you wouldn't be able to do so, at least with the short data type. Now we have something called an int, or an integer. And these are whole numbers that can be in the range of -2,147,483,648, all the way up to 2,147,483,647. And the concept of an int might be familiar to some of you who have taken a math course. It's a slightly different notion because it's bounded by a specific range, whereas in a math class, it's an infinite range of whole numbers, negative to positive. But just know that there is some sort of a parallel that's at least drawn from that. And at first glance, you might look at these numbers and think, okay, well, if we have these data types already and int can store pretty large numbers, then what's really the need to have additional data types of the same sphere that can store even more information? Because it seems like most things would fall into this category. However, there's going to be some real-world examples of information that you want to store that deal with even larger numbers than these. And one example could be, let's say you wanted to keep track of the US national debt. And we already know that one is going to be quite a large number. It's already in the trillions of dollars. So if we wanted to represent something like that in a programmatic form, we wouldn't be able to do so, at least using an int data type. And that's why we have something called a long. And a long can store very large whole numbers up to 9 times 10 to the 18th power. And if you want to visualize exactly how large these numbers can be, or the types that can be, the values that can be supported by the long type, just take out a piece of paper, write down the number 9, and then have 18 zeros that follow it. And that's going to show you exactly what the maximum value that you can store in a long is. So definitely dealing with very large numbers. You shouldn't have to, in any practical application, deal with numbers that are larger than that. In most cases, I'm sure if you wanted to deal with numbers even larger than that, there's capabilities to do so. but we're not going to be covering those, at least in this lecture. The next data type that I want to talk about is also pretty important, and it will have a lot of real-world implications as well, and that is the notion of a float data type. And that stores floating point numbers with up to 7 decimal digits. And the first question that comes to your mind might be, well, what is a floating point number? A floating point number is a number that's represented in decimal form. Let's take 2 over 4, which can also be simplified to 1 over 2, to represent a float. Let's say we wanted to represent that in a float fashion. And we would do that by taking 1 over 2 and converting that into a decimal form, which is 0.5. That 0.5 is what we call in programming to be a float data type. And you can also think of, let's say, items you buy at the grocery store. If you buy things at the grocery store, you'll see that it's not going to be in whole number increments all the time. You could have something that's $1.95 and a bunch of other values with decimal precision. And this is exactly where a float data type could come into play. Then we have the concept of a double, which is very similar to the relationship between a long and an int. That same relationship is then mirrored at the float and double level, where we have the baseline functionality at the float level, but if we want to have even more precision, we would have to use something like a double, which can store even more decimal digits after the decimal point. And the double allows you to store floating point numbers with up to 15 decimal digits, whereas a float allows you to store floating point numbers with up to 7 decimal digits. And then we have one of the most important types in all of programming, and that's a Boolean. So if you think of logical statements, let's think of them as statements that have a definitive answer. And that answer is one of 2 possibilities, either a true or a false. In the concept of programming, there's many statements we're going to be dealing with, logical statements, that will need to define a value that's either true or false. And if we want to represent this in a data type form, you need a data type that can support that. And that's exactly where a Boolean type comes in, because it can store a value to be either true or a value to be false. And we'll go through a number of examples as we're actually writing code using these different data types. But it'll all make sense to you then. This is just, again, a baseline understanding so that we can do things like that in the future. Then finally, we have the data type char, which stores a single letter or a single character. Let's say we choose any random letter of the alphabet, B, and we wanted to store that into a variable. That variable would have to be of a type char, because it's a single letter. Okay. And previously throughout this lecture, we've talked about the fact that string is a non-primitive data type, and that it's a very unique circumstance because it is natively defined with the language, Java, as opposed to other non-primitive data types, which have to be user-defined. It's a tough concept to initially wrap your mind around, but it's a very powerful type, and I think all you really need to be able to pull from this is that string is built in. It provides you an additional set of functionality that allows us to create very powerful Java programs. That's all I really want you to take away from this. I mean, by the technical sense, you can memorize the fact that it's a non-primitive data type, but we'll really go into more depth on why exactly that's crucial later on. For now, I just want you to know that a string essentially stores a series of characters. And some examples of things you can store in the string data type are messages, passwords, sometimes paragraphs, and many other types of text. And I've shown an example below, a visual representation of how a string is going to store some of its information within a computer program. Just think of a string as allocating X number of blocks of memory. It's one block of memory with different segmentations within that memory, and in each of those segmentations within that memory, you can store a different character. Because we've talked about the fact that a string stores a series of character, it makes it very easy to think about in the sense that a string has many different characters, one after another in a specific block of memory. And each of those characters is going to be stored within its own segment of memory. So let's take the word hello, for example. You can look at the word hello and you'll see that we have a block of memory. We have a segment of memory for the H, a segment of memory for the E, then two more segments of memory for the L's, and then one more segment of memory for the O. And a string in Java uses a concept that we call zero-based indexing. Each of these segments of memory that we've been referring to need to be able to be easily accessible. And the way to do that, Java is built in a capability to index these segments of memory, so that if you need to retrieve any information at a specific segment of memory or a series of segments of memory, you can easily do so with the capabilities of an index. And zero-based indexing means that the first segment of memory, rather than starting with what we call counting numbers, which are 1 onwards, will actually start from 0 and then go all the way up. So the H is going to be stored at the 0th index, the E gets stored at the first index, L at the second, and so on. The cool thing to actually see from all of this is that you have a length of a string. In our case, we're using the word hello, and a hello has the length of 5. But you see that the maximum index that is achieved with a word of this size with length 5 is actually 1 less than the length. And that is, again, because of the zero-based indexing that we just spoke about. If I say you had a word that had a length of 2, the maximum index that it would actually be able to get to is 1. So it'll be a 0 index and then a 1 index. But we'll go into a little bit more depth on that in future lectures. But for now, I think this gives us a good enough overview of exactly what we want to pull away from the string type. Back and let's talk about the concept of methods. And we haven't really talked about methods up to this point, but they're a very important concept in Java. And I'm going to do my best to give you a very high-level overview without complicating things to the point that you wouldn't be able to comprehend some of the information that I'm giving you. So let's just jump right into it then. A method you can think about in the simplest sense as code that's reusable and it's packaged together to provide a specific set of functionality for a specific data type. In the context of a string, the method that a string would have would be a very specific functionality that it would provide for that string data type. And methods can take in what us programmers call a parameter. And a parameter is merely an argument that you pass into a method that the method can then use to provide specific functionality and then actually provide you a return value that uses the logic of that actual method and return something as a function of the argument that was passed in. So let's take one example to really understand some of this information. Let's take the char_at function, or the char_at method of a string. The char_at method of this string is going to return a specific character given an index at the string. Let's say we pass in an integer index of 2 to the char_at method that's performed on a specific string. It's going to return the letter that is at the second index of that string. And let's go back to the previous slide so that we can visualize this. Let's say we ran the char_at method on the string hello. What letter do you think will be returned by that method? H, E, the first L, the second L, or the O? For those of you who said it would be the first cell, you'd be correct. And you just wanted to remember the concept of zero-based indexing. And if we were to pass in, let's say, a different index as the argument to this method, it would return an entirely different character. If we were to pass, let's say, 0 as the index, then we would be returned age. So essentially what you want to understand about a parameter is that it's an argument that will return a specific value as a function of that argument that was passed in. And that's exactly what a parameter is used for, to provide different outputs from methods based on the input that you're providing to that method. And we can also have not only one parameter for different methods in Java, we can have multiple comma-separated parameters, we can have multiple parameters passed to a specific method as long as they're separated by a comma. Like in the case of a substring, you have a beginning index, you have an end index. And those are two parameters that we can use. To just wrap this up a little bit and give you a better understanding of at least some of the other functionality that I told you we'd talk about with strings, let's go into a bit more depth on exactly what the equals method does, for example. That takes in a parameter of an object, and essentially what it does is it'll return a Boolean type, so either a true or false value, that tells you whether or not a string is equal to the object that you passed in. Then next we also have an isEmpty method, and it doesn't take any parameters. Some methods don't actually need to have always a parameter. Sometimes they may not have a parameter, just depending on exactly what the functionality of that method is. So the isEmpty method will check whether or not a string is empty or not empty. And if it's empty, it'll return a Boolean value of true. If it's not empty, it'll return a Boolean value of false. Next, we'll have a length method. And this length method returns an integer value that's equivalent to the length of the actual string. So again, in the case of the visual representation I provided to you with the word hello, we would have a length that would be returned with a value of 5 for this particular string, because there's 1, 2, 3, 4, 5 different characters within that string, and each of those characters contribute to that length. Finally, we'll have a substring, which takes the beginning index and an end index, and what it does is it'll return a string that is a portion of the original string that is specified by the range of the beginning index and the end index. So let's say we only wanted to take a portion of this string. The way you would go about doing that is, let's say we want only the H and the E as part of our substring to be returned. You would pass in the beginning index of 0, and you would pass in the end index of 2. And the reason you would do that is because the beginning index is inclusive in the substring, and the end index is not inclusive in the substring. So for you to be able to capture the H and the E, you would actually have to go one index further than the E in order to be able to bring that output to something that you're expecting. Again, these are things that you'll get more used to the more that you use it. But I think this provides us, once again, a decent enough overview of the different methods associated with strings. And now we're on to the final portion of this lecture. So again, a very important portion of Java programming, and it's a concept of variables. Variables are very important because they can store different types of data depending on different types of variables. And you actually have to specify the type of data that you want to store into a specific variable by specifying the type of that variable. The reason you have to do this is because Java is what we call a strictly typed language. What it means at its core is this. It's that you must specify the type of data that you're storing into something before you actually store it there. The reason why variables are so powerful in Java is because they can make life a whole lot more easy for you. Let's say there's an example of a situation where you're performing a number of computations using a constant value of 20. And you have a number of different places where you're reusing the value 20, and then 20 again, and then 20 again. Let's say 2 days later, you've realized that 20 was a wrong number for you to use, and you might actually have to go back and change your code so that it makes those computations using a new value. Let's say 36 now. Now that you want to change to 36, without the use of variables and just using the explicit information of the number 20 that was stored, you would have to then go and change line by line every place that you use 20 to then 36. Whereas if you use the concept of a variable and you store that information, the 20, in a variable that represents its type, in this case it would just be an integer type, and you can store that information and then refer to it in a number of different ways by just referencing the name of the variable that you provided. Let's say you stored it in a variable called a. Anytime you wanted to use that computation, or you wanted to perform some computation, you would actually be referencing the name a, which would then refer to the value that was actually assigned to that variable. So instead of you having to then go and change 20 multiple times, all you would have to do is, instead of assigning your variable a with a value 20, you would just go in and actually assign that variable a with a value of 36 now. And that would make life a whole lot more easy for you, and it makes your programs a whole lot more flexible. And that's only one of the things that it can do. When talking about things such as non-primitive data types, it actually is the only way that you can use what we call methods on that piece of data. And this is, again, something we'll touch upon when we use strings in actual code, when we use other non-primitive data types in actual code. It'll make things a lot more understandable in that sense. And finally, as a portion of this variables understanding, I want to go over some naming conventions. And some of the naming conventions that you can have for variables are that variables are case sensitive, which means that a capital F versus a lowercase f is going to make a difference, and the computer will actually interpret those two things as different variables. So that's something you want to be conscious of when actually naming your variables. The other thing is that you can't use keyword or reserved words as your variable names. So actually, the lowercase word final is a reserved word in Java. And if you were to go and try to use this as a variable name, because that word has a very specific meaning in Java, it would actually throw back an error at you and let you know that that's not a valid name for a variable. Next, variable names generally start with a lowercase letter. And again, these are just conventions that we talk about that are consistent among programmers. So it's important to be able to write code that is easily understood by the larger computer science community, and not just understood by the person who wrote that code. A key part of computer science is being able to share what you do with the rest of the world, and these conventions and adhering to them actually make it possible for you to do so. Next, subsequent characters can be letters, digits, or the underscore symbol, but they can't be spaces. And that's a very important thing, where if you're coming into programming, you're so used to using spaces in the things that you write and so forth, but it's actually not valid in the context of naming a variable. Finally, we want to be able to talk about the use of camel case. You might ask, what is camel case for variable names? And it's a convention that's used for names that require multiple words. Essentially, what it means is that the first word of your variable name is going to be fully lowercase, and every subsequent word that follows after that is going to have the first letter of that word capitalized. So I've included a small example for you, and It's a variable name, small message. The first word of that is small, and you can see it's fully lowercase. The second word is message, and again, as you can see, the first letter of that word is capitalized. So there you have it. That's camel case for you in a nutshell. Finally, we have some examples of assigning variables with values. And in this portion of the lecture, you'll see a recurring thing. You'll see a bunch of equal signs in a bunch of different places. And in Java, one singular equal sign is not actually saying that something is equal to something else, but rather what it's saying is that you're assigning something to something else. And what that means in Java is that you're actually assigning whatever is on the right-hand side of the equal sign to whatever is on the left-hand side of the equal sign. And what we're doing here is what we've talked about in this lecture, but we haven't actually shown you any examples of how to do that. And that's assigning values to specific variables so that you can then refer to variables in pieces of your code as opposed to referring to different explicit values. So instead of you having to perform computations with the number 4 all the time, you can just go and reference that variable by just calling whatever the name is. So the name isn't actually int a, because int is just you specifying the type, but the name is actually a for that first variable that we see right there. Anytime you want to use, let's say, 4 times 12, another way that you can represent that is a times 12, because what a is representing is just that 4 that was initially assigned to it. So there you have it. That's the first example that we've gone through. We can see another example of that when we're taking a decimal number and we're assigning it to a float. And we can look at float b equal 4.0, and then you can see that you're assigning whatever is on the right-hand side to whatever is on the left-hand side. Next, you'll have a string message, and in this message, you'll notice something that doesn't actually make sense to you, but is a very crucial thing for you to understand about the string data type in Java. It's that whatever you actually want to represent in a string format, you will actually have to encompass in opening and closing double quotes. If you don't do that, it's not actually a valid representation of a string. So you won't be able to use it in the way that you want to. So we have a small message. It just says this is a small message. We've enclosed that with opening and closing double quotes. And then we're assigning that to what we call a string variable. And we've done so in the way of string message equals, and then we have our enclosed string, and it's assigning whatever is on the right-hand side of the equal sign, again, to whatever is on the left-hand side of the equal sign. And next we have a car letter. And we're seeing that similarly, whereas a string uses double quotes, a car actually has to be encompassed in singular quotes. So car letter equals A is really saying that whatever's enclosed in that single quote, A is the representation of a car, and we're assigning that representation of the car on the right-hand side of the equal sign to whatever car letter allocation is on the left-hand side of the equal sign. So anytime we want to refer to that A, we can just refer to letter as opposed to actually referring to that A explicitly every time we want to use it. And finally, we have Boolean verified equals true. And a key thing to note here is that if you want to assign a true or a false value to different Boolean variables, and you're going to use the keyword true and false are both keywords in Java, they both must be lowercase. And that's why you can see that I've shown Boolean verified equals true, with true being in all lower cases. That's assigning the value of true from the right-hand side of the equal sign to then the left-hand side of the equal sign in the Boolean verified. And with that, that covers everything I wanted to cover through this third video of the Java track. I know there was a lot of information that was provided throughout this lecture. It's going to be a lot that you'll have to take potentially some notes on, and a lot you'll have to continue refreshing. It's not something that I anticipate you'll get immediately on the first shot, especially because of the breadth of everything that we've gone through with this specific video. But it is something that I hope you'll go back to, you'll reference, you'll look up some subsequent information that can help you out, potentially on sites like Stack Overflow and other sites along that same path. But if you do have any questions, definitely reach out via the Contact Us page on GenCode. Excited that I get to continue being a part of this Java track, hoping that it's giving you guys some valuable insights into the world of computer science and also helping you strengthen your Java programming skills. So you continue to progress through this course. There's going to be a lot more information that's provided to you, and by the end, you'll all be expert Java programmers. So I'm excited to see all of the different products that you guys can produce as a result of everything you learn in this course. With that, I'll be signing off, and thank you for watching.